Hello everyone. Today we will discuss about process scheduling algorithm, that is FCFS. First come first serve. First come first serve CPU scheduling algorithm is considered as the simplest CPU scheduling algorithm. With this scheme, the process that requests the CPU first is allocated the CPU first. This implementation of FCFS policy can be easily managed with FIFO queue, that is first in first out queues. When a process enters the ready queue, its PCB, that is process control block, is linked onto the tail of the queue. When the CPU is free, then it is allocated to a process at the head of the queue. The running process is then removed from the queue as the running process status is now changed from ready to running. Now let's understand how first come first serve CPU scheduling algorithm works. To evaluate the algorithm, we basically used CPU scheduling parameters, and these parameters are waiting time and turnaround time. To understand working of FCFS, consider the example below. We have given some processes along with their burst time. So process P1 with burst time 24, P2 with burst time 3 and P3 with burst time 3. Here, three processes are given along with their burst time. That burst time may be given in milliseconds. Now consider arrival time for all these processes as 0. That means all processes arrived at the same time. However, order of arrival is P1, P2 and P3. Assuming that the processes arrived in the order P1, P2, P3 and are served in FCFS order, that is first come first serve. So here what will happen? Process P1 will start execution at t equal to 0. So process P1 will start at t equal to 0. Process P1 will complete the execution at t equal to 24 as its burst time is 24. So at t equal to 24, process P1 will complete the execution. Now process P2 will start to execute at t equal to 24 and will complete the execution at t equal to 27. So here you can see P2 started at 24 and P2 completed at 27. Now finally the process P3 will start to execute at t equal to 27 and it will complete the execution at t equal to 30. So here in diagram you can see P3 started at 27 and it getting completed at 30. Alright. So we get the result as shown in the Gantt chart. So this particular diagram is called as the Gantt chart. Here I have mentioned it as a Gantt chart. What is Gantt chart? Gantt chart is a bar chart that illustrates a particular schedule including the start and finish time of each of the participating processes. So process P1 started at t equal to 0 and completed at t equal to 24. So that is start time and end time for process P1. This is nothing but the Gantt chart. Now let's calculate the turnaround time for each of the processes given below. Here Gantt chart is given. Okay, from this Gantt chart we will be finding the turnaround time of the process. So assuming that for process P1 arrival time is 0 and it started to execute at t equal to 0, alright, and it kept the CPU till its completion. So P1 completed at t equal to 24. So as per the definition of TAT, that is time from submission of the process to the completion of the process, that becomes, let's say, from 0 to 24. So turnaround time for process P1 becomes equal to 24. Now let's understand turnaround time calculation for second process, that is process P2 with arrival time 0 and burst time 3. So same Gantt chart we will be using. As arrival time is 0 and it started to execute at t equal to 24 and kept CPU till its completion. Here P2 completed at t equal to 27. See here, started at 24, completed at 27. However, submitted at 0, arrival time is 0 for P2. So it has to wait from 0 to 24, got control at 24 and completed at 27. So turnaround time of P2 is 27. Then finally process P3 with arrival time 0 and burst time 3. Same Gantt chart we will be using here. Arrival time is 0 and it started to execute at t equal to 27 and kept CPU till its completion. P3 completed at t equal to 30, so the turnaround time for P3 is 30. We can see here P3 started at 27, completed at 30 because its burst time is 3. Right, it is submitted at t equal to 0, so from 0 to 30 that becomes its turnaround time. So that is nothing but turnaround time for process P3. Now let's calculate the waiting time for each of the processes. We have seen the turnaround time, now waiting time. So same Gantt chart we will be using here, and then for process P1, see the arrival time is 0 and it started at 0. Alright, so waiting time for process P1 is 0, that is starting time minus arrival time. Okay, so waiting time is 0 for process P1. Then for process P2, arrival time is 0 and it started to execute at t equal to 24. See here, arrival time is 0 and it got control at t equal to 24. We are talking about process P2. That means process P2 has to wait from 0 to 24. That means waiting time for process P2 is 24. Then finally for process P3, see here it is arrived at 0, it is started at 27, that means from 0 to 27 it has to wait. That's why the waiting time for process P3 is 27. So finally we can draw the values of waiting time and turnaround time in a tabular fashion like this. We have the processes, then we will mention their burst time, then waiting time and turnaround time. So for process P1, burst time is 24, its waiting time is 0, turnaround time is 24. For process P2, burst time is 3, waiting time is 24, that is nothing but the turnaround time of process P1, and turnaround time for process P2 is 24 plus 3, that is 27. Then for process P3, burst time is 3, then its waiting time is 27 and the turnaround time is 30. This is nothing but the FCFS CPU scheduling algorithm. I hope you have understood this. Thank you.